Hello, hello. We are back with example 5 where we are going to be writing and solving an equation for the application. So this first question says a person's maximum heart rate is the highest in beats per minute that the person's heart should reach. One method to estimate maximum heart rate states that your age added to your maximum heart rate is 220. Using this method, find the maximum heart rate of a 15-year-old. So what they want us to do is they want us to write and solve an equation. So what we have to do is there's a lot of information there. We need to determine what is the information that is going to help us come up with an equation. And what I see here is this sentence right here. One method to estimate your maximum heart rate states that your age, so your age added to your maximum heart rate is 220. So that is our equation. Okay, so the first thing is your age, right? So we have our age added to maximum heart rate. Heart rate is, that means equals 220. Okay? So let's go ahead. We don't want to write maximum heart rate and we don't want to write age. So let's say let A equal age, and how about M equal maximum heart rate. So what I'm doing is I'm defining these variables so I don't have to write out all the words. So now instead of age, I just write A plus maximum, A plus M equals 220. There's our equation. Now it says using this method, find the maximum heart rate of a 15-year-old. So the age is 15. So I'm going to say let A equal 15, and I'm going to substitute that value in for A. So now we have 15 plus M equals 220. Okay, and this is probably my equation, right? That they're saying write and solve an equation. So that's that. Now I'm going to solve it. So I'm going to get M by itself. So I'm obviously going to do the inverse operation of addition, which would be subtracting 15 to both sides. Those cancel. I'm left with M equals 205, which would be the maximum heart rate of a 15-year-old. Heart rate of a 15-year-old. Okay? So there we go. That's how that one works. That's how we write an equation. Make sure there's the answer, we solved it, and make sure you have that concluding little statement. Okay, let's go ahead and look on to B. It says, over 20 years, the population of a town decreased by 275 people to a population of 850. Find the original population. Okay, so like I said, they want us to write an equation, so we need to look at this and figure out, well, where is that equation coming from? So it says over 20 years, the population of a town decreased. So we have population of a town decreased by 275 people to a population of 850. So what I don't know, the population of a town, that is the original population of the town. I'm going to go ahead and define my variable. I don't know that. I'm going to call that x. So I'm going to say let x equal original population of town. Okay. So here we go. Population of town, that is my x. So I'm going to write x decreased, means subtraction, by 275 people. So it's minus 275 to a population. That pretty much means that it equals 850. So here's my original population that I started with. It decreased by 275, and now we're at 850. So we're gonna go ahead and use algebra to figure out what that original population is. So at this point, this is the equation part of my answer. All right, that's that part. And now I'm just gonna solve it and figure out what the original population is. So to do that, inverse operations, obviously. So I'm gonna add 275 to both sides. I end up with x equals, that would be 5, 2, 1, 10, 11. So there's the original population. So the original population was 1,125 people. And there we go. That's how that one works. All right, let's do a couple more. I think with story problems, it's always good just to have lots of practice, because the more practice you have, the more confident you feel seeing a variety of different examples. Okay, so we're just writing and solving an equation for the application. This says Kiro puts 1/4 of the money he earns from mowing lawns into a college fund. This year, Kiro added $285 to his college education fund. How much money did Kiro earn mowing lawns this year? Okay, so we are looking for an equation. Okay, so 1/4 of the money he earns from mowing lawns into a college education fund. So 1/4 of 1/4, that's a key part, of that means multiplication. So 1/4 times the total money he earns goes into an education fund. Okay, so we're gonna write that equation. The money he earns from mowing lawns. Let's go ahead and make that a variable. So let's say let x equal total money earned from mowing lawns. Okay, lawns. Perfect. So here we go. 1/4 of means times money he earns from mowing lawns. Okay, that's our x, total money earned from mowing lawns. So that's going to be our x. So 1/4 times x into a college fund. So 1/4 of the total money equals how much money is put into the education fund. And it says this year he added $285 to his college education fund. So that means this college education fund right here equals $285. All right. And I'm just going to rewrite this as 1/4 x equals 285. And that is going to be my equation for this problem. Now we're going to solve it, right? We're going to get x by itself. So we have 1/4 x equals 285. And I'm just going to, this is really divided by 4. The inverse operation of dividing by 4 would be to multiplying by 4. Or I can multiply by the reciprocal, which, you know. So I'm going to times this by 4. 4 divided by over 1 is just the same thing as 4. So all this stuff cancels out, becomes 1. 1 times x is just x equals 285 times 4. I don't know what that is. I'm going to go over here to the side and just figure out what that is real quick. 4 times 5 is 20. Write the 0, carry the 2. 4 times 8 is 32, plus 2 is 34. Write the 4, carry the 3. 4 times 2 is 8, plus 3 would be 11. And there we have our answer right there. So how much money did Kiro earn mowing lawns this year? The total amount of money from mowing lawns was $1,140. So total amount of money earned from mowing lawns was $1,140. That's quite a lot of money. Must have really been working hard. All right, perfect. Let's move on to the next one. It says an orange contains 80 milligrams of vitamin C, which is 10 times as much as an apple contains. Find the amount of vitamin C in an apple. Okay. An orange contains 80 milligrams of vitamin C, which is 10 times as much as an apple contains. Find the amount of vitamin C in an apple. So what's the thing we don't know? We don't know the amount of vitamin C in an apple. So I'm going to go ahead and define my variable. I'm going to say let X equal amount of vitamin C in an apple. Okay, so we have X. Now we want to find our equation. So it says an orange contains 80 milligrams of vitamin C, which is, so that's 80 means 80 equals 10 times, so 10 times is multiplication, as much as an apple contains. So as much like vitamin C in an apple. That's what that's referring to. So if we write this equation, we have 80 is 10 times the amount of vitamin C that an apple contains, which would be X. Or just 80 equals 10X. And there's our equation. Perfect, perfect. Now we're going to figure out what X is. So we have to get X by itself. Right now it's being multiplied by 10, so we have to do the inverse operation of multiplication, which would be division. We're going to divide both sides by 10. 10 divided by 10 is 1. 1 times X is just X. And 80 divided by 10, 10 goes into both of those. 10 goes into 80 8 times. 10 goes into 10 1 time. So we basically have 8 divided by 1, or just 8. So the amount of vitamin C in his apple is 8 milligrams. So we can say there are 8 milligrams of vitamin C in an apple. And there we have it. So we have our equation there and our answer. Okay, and we showed all that work. So this is how your homework problems will need to look, what they'll need to look like. Okay, let's go ahead and do this last one. It says your weight on the moon is about 1/6 of your weight on the earth. How much does a person weigh on the earth if he weighs 16 pounds on the moon? All right, perfect. So, we have a couple different things. What are the things we don't know? Weight, your weight on the moon, right? So that's going to be one variable. So let's say M equal weight on moon. And how about we let E equal weight on the earth. Okay? So those are the two things that we don't really know. But let's go ahead and find the equation. It says your weight on the moon. So weight on the moon, what variable do we have for that? M, right? So M means equals about 1/6 of means times your weight on earth. And remember, our weight on earth, we're using E. So there's our equation right there. M equals 1/6 E. Okay, but it says how much does a person weigh on earth if he weighs 16 pounds on the moon? So that means M is going to equal 16. So we substitute 16 in for M, and we end up with 16 equals 1/6 times E, which I think that is the equation that they're looking for. Now we need to determine what is that weight on the earth. So we're just going to solve it for E, get E by itself. Use our algebra. So 16 equals 1/6 E. Okay, and we're going to do the inverse operation by multiplying by the reciprocal, 6/1, right, to both sides. Those 6's cancel out and become 1s. All this is just 1 times E, which is E. And then we have 16 times 6. I don't know what that is off the top of my head, so I'm going to go over here to the side and figure it out. 6 times 6 is 36, right? The 6 carry the 3. 6 times 1 is 6, plus 3 is 9. So 96 would be 96, yeah, pounds. Okay, so if a person weighs 16 pounds on the moon, they will weigh 96 pounds on Earth. All right, there we go. All right, awesome job, and we will see you next time. Goodbye.